All right, 553. So, couple of things we have to, some notation, not notation, definitions we have to learn before we can look at the trig function graphs. Because they're periodic functions. You might have seen this in physics. There's what's called the period of the graph and the amplitude of the graph. Period is just basically how often it repeats itself. Okay, so let's say how often the graph repeats. So the easiest way, there's a couple of different ways. You can measure the distance from peak to peak, or you could do midpoint to midpoint. I'll show you what these mean on a graph. Or you could do, I call them troughs, but the bottom. Trough to trough. And period, we're obviously going to represent with the letter P. So for the first graph here, if I said, what is the period? What's the distance between the peaks? That distance is the period. 10 minus 2 equals 8. You could measure the difference between the bottoms or the troughs, which is 14 minus 6, which is 8. Or you could do the midpoints. So what I mean by midpoint is that distance. All right, that's the midpoint of the graph. It's equidistance between the top and the bottom, which would be 8 minus 0. Obviously, most people just do peak to peak if it's easy to measure. Does that make sense? Yeah. Physics people are probably like, yeah. That's called the period. So in the next graph, we'll do amplitude in a sec. What's the period of graph B? 6. If you measure the distance here, 9 minus 3, you get 6. Or you could do the difference between the bottoms, which is 6 minus 0, which is 6. Midpoint's a little trickier with this one because it's not right at the x-axis, right? But you could still do it, or you could just measure the distance between where it hits the x-axis when it's going up. You're not going to measure it to this distance because the graph is falling at that point, right? You got to wait till the next part where it's rising, which is right there. So 7 minus 1 is 6. Peak to peak's the easiest, or trough to bottom, trough to trough. What's the period of the last one? This one's a little trickier. It's 10. Because if you go from this point, that's when it's about to fall. You go to the next point where it's about to fall, which is right there. So it's going to be 10. Does that make sense to people? This is really important, setting up what we're going to do in the next few days. We're okay with that? Yeah, I don't know. All right. Okay. Amplitude. Amplitude actually has a formula. Amplitude is half the distance between the max and the min values. Basically, you just go max minus min and divide by 2. That's your amplitude. So, in the first one, what's the maximum value? 10. What's the minimum value? Negative 10. What's 10 minus negative 10? 20. 20 over 2 is 10. If you have a graph that is like centered at the origin, basically, it's just the distance from the origin. But as you can see in the next one, it's been moved up. It's not centered at the origin, so it's a little trickier. So what's the maximum of graph 2? 6. The minimum is -2. Divide by 2. 6 minus -2 is 8 over 2, which is 4. So it has an amplitude of 4. And the last one, what is the amplitude? Six minus -2, because the minimum value is 2. Divided by 2, which is 4 over 2, which is just 2. That's period, that's amplitude. Period is how often a graph repeats itself. Amplitude is the distance or the difference between the max and the min, basically. All right. Are we okay? Go to the next page. This right here. All right. I need you to have your calculators out, please. We're going to do degrees, please. Because it's just not as easy a number. I mean, we can do it if you really want to, but yeah, it's not a. All right. So in your calculators, punch in sine of 0. What is the value of sine of 0 in degrees? 0. What is sine of 30? Yeah, it's a half. I'm going to actually write the decimals because I want the decimals just because for the graph. But it's a half. What's 90? What's 150? It's 0.5. What's 180? 0. What's 210? Negative 0.5. What's 270? Negative 1. What's 330? Negative 0.5. And 360? 0. Okay, we're going to plot these points on the graph. So, when x, on the x-axis you have your degrees, on the y-axis you have the value of the function. So, at 0, it's 0. At 30, which is right there, it's 0.5. What the hell's 0.5? Which is right there. At 90, it is 1. Is it? No, it's not. I can't count. It's like right there. At 90, it's 1. At 150, which is right there, it's at 0.5 again. At 180, it's 0. At 210, we're at negative 0.5. 270, we're at negative 1. 330, we're at negative 0.5. And 360, we're at 0. If you connect those lines, that's the sine graph. Okay? It has a max of 1 and a min of -1. It never goes above those two numbers unless you add an a value. Remember a values? We're going to do that in the next couple of days. All right?
Well, two variables are a. Like, you have the amplitude.
You would write capital A amplitude or something, or say that. But yeah, a value, it could be, you could use any letter for it. It's just a vertical expansion. All right, so it always oscillates between 1 and -1. That is the period. The period of this graph, if we go to the bottom, the period is 360 degrees. A sine graph repeats itself every 360 degrees. What is the range of the graph? 1 and -1. Range is the y values, right? So range is always 1 and -1. I should have written it this way. That's better. Okay. It just oscillates between 1 and -1. What's the domain? Not really, because it can go forever. So you can create the domain to whatever you want, but this graph, I can actually extend it. At 450, you go back up to 1. 540, you go to 0. And it can go in the negative direction. That's a bad sine graph. That is what the sine graph looks like if you give it no domain restrictions. It just goes on forever, just going up and down, up and down, up and down. That's all it ever does. All right? And all that stuff I told you about the add sugar to coffee, all students take calculus. If you look at the graph, 0 to 90, that's quadrant 1. 90 to 180 is quadrant 2. There's quadrant 3, and there's quadrant 4. So you can see visually why sine is positive. Well, not why, but you can see that it's positive in the first two quadrants and negative in the second and third, or the third and fourth quadrant. So if we're going to write the domain for this, we're going to say all real numbers, or so you can all real, or you can just say negative infinity to positive infinity. Yeah, you're right. Since we use theta. Oh no, they used x up there. So, but if you wrote theta, what's the amplitude of this graph? It's 1. What are the x-intercepts of this graph? What was that? So if you wrote them out, you would get 0, 180, 360. You can see them. Boom, boom, boom. Or what could you write, Mr. Sadler?
180n. Oh, n pi.
Well, you can do in rads if you want. Yeah. So n is an integer. Is 0 an integer?
Oh, 180 w. No, 180 I.
0 is an integer, though, right?
Yeah.
Yeah. So it's just, you can just say n180 or whatever I or whatever the symbol for integer. That's lowercase I, though, isn't it?
Well, I thought he was giving me trouble for using n for natural.
No, I'll just write n. That doesn't. I'd say I.
N like an integer, any number.
N-E-I. There we go. There. N-E-I. N is any integer. So it's a multiple of 180 degrees. I'm not going to ask you that. Yeah, that's what we were just talking about.
Yeah. 0 times 180.
All right. What's the y-intercept? 0. There's only one of them. Okay. You need to know the sine graph.
Are you doing cosine as well?
Yeah, I'm going to do it right now. So look, if you're in Math 12 and this is the end of your mathematical career, just write it on your sticky note cheat sheet. You'll never be asked to repeat this ever again. If you are going to calculus, you need to know this graph. Okay? And it actually makes things easier to solve if you know this graph.
Yeah, this is much nicer than the unit circle.
Oh, I hate that. I hate the unit circle.
I always
Yeah.
just draw the sine graph and the cosine graph.
That's what I do. And I use special triangles too. So
Yeah, I didn't know those for a long time. I forgot them.
All right, peoples, cosine. Here we go. Here's what I want you to do. This is just turn the page, please. We got 6 more minutes. We can do this. Tell me, we're not going to do pi over 6. We're not going to do 5 pi over 6. 7 pi over 6. None of the pi over 6s. There we go. All right. What is cosine of 0? No. What's cosine of 0? The angle is 0. I'm saying, what is cosine of 0? It's 1. What's cosine of pi over 3? First of all, what's pi over 3?
60 degrees.
60 degrees. So what's cosine of 60? 0.5. What's cos of pi over 2? What's pi over 2? It's 90. So what's cos of 90? 0. There you go, 0. What is cos of 2 pi over 3? What's 2 pi over 3? That's 120. So what's cos of 120? Negative 0.5. What's cos of pi? Negative 1. What's cos of 4 pi over 3?
Oh, is it negative 0.5?
What's 3 pi over 2? It's 0. And 5 pi over 3 is 0.5, and 2 pi is 1. All right, this is the cosine graph. It starts at 1. Cosine of 0 is 1. Everybody messes this up. It starts at 1. It has at 90 or pi over 2, which is right there, its value is 0. At pi, I'm just going to do the nice whole numbers. At pi, it has a value of negative 1. At 3 pi over 2 or 270, it has another x-intercept, a value of 0. And at 2 pi, it's 1. Cosine graph looks like this. That is the cosine graph. What do you think it does? Do you think it stops there?
No, it goes on.
It goes on forever too. So that is the cosine graph. The only difference between the cosine graph and the sine graph, they've been shifted. But the big thing you need to remember is cosine of 0 is 1. It starts at 1. Okay, we'll quickly do the domain and range, and then we're done for today. What's the domain of this graph? I'm going to write it right here. Domain is all real numbers, negative infinity to positive infinity. What's the range? Negative 1 to positive 1. It's the same as the sine graph. They oscillate between 1 and negative 1. The amplitude, max minus min, so 1 minus negative 1 over 2. It just gives you 1. The period, how often does it repeat itself? 2 pi or 360. What else did I ask in the other one? I don't even remember. X. Oh, what's the y-intercept? What? Y-intercept is 1. X-intercept What is the x-intercept? Where do they occur? So let's look at them. Where's this one? That's pi over 2, 90 degrees. I'll do it in degrees just because most people will make sense. So the x-intercepts are 90, 270, ... How would you represent that?
You just go 90 times n. Because it's increments.
So if I make n 2, I should get 180 then, right?
Okay, so you make sure that n is always odd.
So you go 90 plus n 180. And NEI. Look, I'm not going to ask you that, but the x, it means NEI means n is an integer. So if I say n is equal to 1, or say we'll say 0. If n is 0, 0 times 180 is 0, plus 90 is 90. That gives me the first one. If I make n 1, it's 90 plus 180, which gives me 270, which is the second one, et cetera, et cetera, et cetera, et cetera. You don't have to know that. What you do have to know is the trig graph, sine, and cosine. Tomorrow we'll do tan, but tan we don't use as much because it's a really weird graph. From today, remember those two graphs because we'll start using them tomorrow. That's all you have to remember. And the sheet that we did at the beginning of class.